Hey everybody, it's Mr. Richards here, and this is the programming number 6 assignment for the week of March 22nd through the 26th in robotics class. Now this week we're going to start doing something a little bit different, and this is going to do with our desired behavior. Okay, so remember, first of all, when we write code, we always identify the desired behavior first, so that's just figuring out what we want the robot to do in the real world. Then we break that desired behavior down into steps and write those steps out as comments in our coding space. And we technically call that pseudocode. It's just the code or the steps that we read as humans in English. Then we identify the code that will accomplish each step and add it in after each piece of pseudocode, after each step that we've written out as a comment. Finally, we're going to proofread and check for errors and then download a program to the robot and try it out if we're in the real classroom. So we're going to be using a tank. Remember, a tank has a motor on each side, all right? And the way that we make that tank move is if both motors are moving in the same direction at the same speed, the tank will move in the forward or reverse direction. If we want the tank to turn or spin, then we have either one motor off while the other one is on, or one motor is moving forward and one motor is moving backwards. Okay, so here's where the change is. All right, your desired behavior is actually a sort of course, and it's a pretend course, but it's around a box. Here's your box, this square right here. And what you want your robot to do is start at one corner of the box and move around the box in this direction, okay? And finish at the same corner that it started at, okay? Now, technically, we're going around in an anti-clockwise way, which means that we're taking left turns every time we get to a corner. Now, this is a little bit more complicated than normal because normally I would write out the desired behavior for you and then you would just copy and paste it into your coding space, break it into a list, and then write out your code. But this time, you're the one that has to actually start and figure out what are the steps of this desired behavior, okay? And I'll walk you through that right now. A couple of important things before we get started with this is that I'm telling you that it will take 5 seconds to move all the way down one side of the box. Each turn will take 1 second to complete if you have one motor stay stopped while the other motor is moving at full speed. It takes 1 second to complete a turn, and it's just a 90-degree turn in this case. All right, each side of this box is the same length, and each corner turn is going to be exactly the same as well. So if you think about it, we're really just doing the same set of behaviors, move forward and then turn left. We're just going to do it a total of 4 times. All right, so that's our desired behavior. So let's switch to our coding space. And I've got that right here. So here's our coding space, and I'll make the writing just a little bit bigger so that's easier to see. Maybe a little bigger than that even. Okay, so remember we're going to go around a box, and the first thing that we have to do is move forward in a straight line for 5 seconds because that's how long it takes to get along one side of the box. So our desired behavior is going to be move forward at full speed for 5 seconds. Okay, that's the move along one side of the box. The next desired behavior that we're going to do is we need to make a left turn. Okay, so make a left turn. And to do that, let's think here. If we need to make a left turn, all right, let's say we have a robot that has a motor on the left side and the right side. Okay, this is 2 motors here, and it's kind of, goofy looking, but whatever. So there you go. We got a left side motor and a right side motor. A left turn is in this direction. So which motor needs to stay stopped or basically stay in place, and which motor needs to be the one that turns? All right, well, think of it if you're playing basketball ever, you know that sometimes you have to plant your foot and pivot. Well, in this case, the foot or the motor that needs to be planted is the left side motor. That motor is basically going to stay in place while this right side motor turns and brings the right side up to here. All right, and that will get you that left-hand turn. So our left turn is really going to be right motor full speed for 1 second. Okay, so there you go. That's here's our desired behavior to move it straight. Here is our desired behavior to make it turn. And now let's make sure that we have the right number of these each time. So we need to move forward for 5 seconds, and we need to make a left turn, and there's 4 sides of the box. So we need to make sure that this is repeated 4 times. I'll get a space in there. 1, 2, 3, 4. Okay, 1, 2, 3, 4. And the last time you don't have to put a turn in there, because the finish, you can just finish at the corner. So we can take that turn out if you want to. You don't have to. You can make it turn again. Now, why did I copy and paste all of these steps at the beginning? Doesn't this look really kind of busy and overwhelming? Well, yes, but remember, when we have a desired behavior for a robot to do, we want to write down all of the steps that the robot needs to complete. Okay? And so we've done that. Hopefully what you've noticed, though, is that there's only 2 different things. There's the moving forward and the taking a left turn. And we just can copy and paste that for each of these steps here. Whatever we type in here for the moving forward, we can copy paste it here, copy paste it here, and copy paste it here. And for the left turn, we can copy paste it here and here. All right, so that hopefully breaks down the work a little bit. Now this move forward at full speed is something that we've done a lot, okay? That's going to be our simple start, run, stop command, and we need to have both motors turned on. So I'm going to do start motor, and we're going to do motor R for our right side motor and set that speed at full speed, which is positive 127. We need to make sure that we're starting the other side of the robot, so that'd be motor L, and I like to call them motor R and motor L just to keep them straight. In this case, that's really helpful for doing our turn. So now we've started both motors. We have to run them for 5 seconds. And then we need to stop both of them. So stop motor, motor R, and stop motor, motor L. All right, so there we go. Now there's one last thing that we should do in here, and this is something that I talked about a couple weeks ago, and that is every time we have a motion that our robot does, we should put a pause afterwards. And that's because in the real world, these robots have inertia, meaning that if we don't give them time to speed up, slow down, and change direction, they're going to skid, flip, and freak out. So at the end, I'm going to put in a wait for 1 second. Cool. So there's our moving forward. Okay, let's move on to the next step, the left-hand turn. Okay, so I could have written this up a little better. The right motor at full speed for 1 second. Okay, to make a left-hand turn here, remember we talked about how what we need to do is keep that left motor, that left wheel, or the left tread in this case, stationary, which means the left side motor stays off. Now, what that means is that you only need to turn on the right side motor, and we only need to turn it on for 1 second. So this turn is actually a pretty simple little bit of code. We're going to do start motor. We're going to do motor R and a speed of 127. We need it to go for 1 second, so we do wait for 1, and then we need to turn it off. All right. So this is going to get that left-hand turn to happen. And again, because we just did a motion, let's put in a wait for 1 second afterwards, just to make sure that our robot doesn't do some weird flip or skid or something. All right. Well, now we have both of our unique desired behaviors, or we only have 2 different steps that the robot needs to do. Move straight along one side of the box and take a left-hand turn at each corner. And remember, that's right here. Okay, we need to move straight along one side of the box, make a left-hand turn, move straight along one side of the box, make a left-hand turn, straight along the side of the box, left-hand turn, straight, and then stop. Okay, and so hopefully this code will make that happen. Now we can copy and paste, but here's a, I don't know, a pro tip, I guess if you want to call it. Make sure you proofread now. Once I copy and paste this, I'm going to have exactly the same thing repeated 4 times, which means if there's a mistake, you have to fix it in 4 places. So proofread before you copy and paste. Take a look. No misspellings. This all looks good. I've got motor R, 127. I got my semicolon. Same here. Motor L, 127 semicolon. I'm not missing anything here. I've stopped both motors. I've spelled everything right. Motor R is spelled the same way here and here. Motor L is spelled the same way there and there. I've got my weight at the end. Okay, I'm good to copy and paste this. So I'm going to highlight it. I'm going to copy. And every time I see this move forward at full speed for 5 seconds, I'm going to paste it in. There's one. I can put some little white space in here. Make sure it looks right. And last one. All right. Okay, now you can see that very quickly code can get very long, and that's why we have to make sure that we have this pseudocode written in here, because I knew that it would take 4 times going in a straight line in order to get this robot all the way around this box. 4 moving in a straight line, 3 left-hand turns. And since I wrote that out beforehand, I know exactly how many times I need to copy and paste this set of instructions, okay, or this set of code. Now I can do the same thing with that left turn. All right, every time I see a left turn, I'm going to paste it in. There's 1, and I only had to do it 2 more times for a total of 3. Now we have this really neat, here's what the pseudocode says, here's the actual code that'll make that happen. Here's the pseudocode, here's the code that'll make it happen, and so on and so forth. Okay? This is how much code it takes to get a robot to move in around a box or around a square. Okay, and I'm not doing this to freak you out. I'm just showing you that you end up with a lot of lines of code. And so it's essential. Make sure that you have the desired behavior split into steps, written as comments. We call that whole thing, we call it pseudocode. So you have to have the pseudocode written out for yourself. All right. Then also make sure that you're making good use of the copy and paste function so that you don't end up wearing out your fingers doing so much typing, especially if the same behaviors are repeated multiple times. Okay? All right, that code should make this robot start in this corner and go around this square course. Now remember, if you have any questions, you can always send me an email. Even though I'm doing in-school support Monday through Thursday from 9:30 until noon, I'm always available to hop on a Google Meet with you at that time if you need a little bit of extra help. You can also email me and we can communicate over email. And I teach the robotics course several times during the week. So if you have an open period or a foundations or something and you're able to jump in the class a second time, just email me and I can tell you when I'm teaching this again. Sometimes that might help kids. All right. Have a great time doing this assignment, everybody.